Hello everyone, I'm Natwela Francis, presenting our project with classification of fruits according to freshness using artificial intelligence. To start the problem being investigated. Usually people face challenges in identifying the rotten fruits from a large collection of fruits. This can be during the market days, purchases from supermarkets, or juice making factories when identifying which fruits to be used in the process. So this model that we are developing will be able to solve the problem where I find people need get to get the rotten fruits from the fresh fruits when selling, let's say in the factories where they make fruit juice, they need the fresh fruits when making the juice. So this AI model is able to detect which fruits are rotten, and it can separate them from the fruits that are really fresh and are needed. That's the problem we're solving. The background of this AI model or project, usually when separating fruits from the rotten fruits from the fresh fruits, it has been being done manually by the people, where it is time wasting, it is boring, and it's not even accurate. Where you find someone is tired, but still he just he find this a rotten fruit in the fresh fruits. So the background of this AI project, we'll have to get back to that background, how people separate the rotten fruits from the fresh fruits manually, and use that same knowledge to do it actually using artificial intelligence, where you're using the cameras to detect those fruits that are rotten with a percentage accuracy, where you find if the fruit reaches a certain percentage, then it is classified as a rotten fruit. Then it's separated from the fresh fruits. And yeah, the responsibility of this model, it will be accountable, where you find once the fruit is rotten, or it is selected as rotten when it's not rotten, then accountability has to be on the developers. Yeah. Talking about the significance of this project. Being a model that will be able to classify the rotten fruits and the fresh fruits. It is going to be used later to make industries, whereby you find the fruits. Where in industries, usually there's a conveyor belt where fruits are running. Probably they're coming from the collection center and they're coming to the machines for cutting and then processing. So this model will be having cameras, whereby the camera has always been video mode, so it captures all the fruits. It has to be controlling itself. But and yes, where I find in the conveyor belt, once a fruit reaches the point, the camera like, touches captures every fruit. Then where the fruit has a certain percentage, depending on the quality that we are using. That's the shape, the color, plus the texture also that will be used, whereby you have to determine because when a fruit gets to some level of getting rotten, its texture changes. Yeah. And hence, like as the slides, is thereby to detect the quality of the fruits, that is whether they are rotten or fresh, and can be used to determine whether they are worthy for health consumption by the customers. Yeah.
My name is Kemba Wazisandra Aine, and I'm just going to begin from where we had stopped. So the next slide that I'll be explaining is about the project scope. Project scope, the model to be developed is to detect rotten fruits from a large collection of fruits. And here we're going to be dealing specifically with fruits that are used to make juice. For example, in industry, we are dealing with fruits that are being used as raw materials in industries. There could be fruits that you can make from home and you need to determine whether they are rotten or not. But here specifically, we're going to deal with a large collection of fruits that is set in an industry. So here in the industry, they need to like separate the ripe fruits, the fresh fruits from the stale fruits that have gone bad and are not good for consumption. Yeah, so the scope is only going to be dealing with those fruits that have been brought to the industry and are supposed to be differentiated in order to produce juice that is worthy of consumption by customers. Yes. And then a problem statement like we've been discussing is farming being the backbone of Uganda's economy needs to be modernized. Yeah. So imagine all these countries that rely on Uganda, for example, for food, for not specifically even rely on Uganda, but countries that Uganda exports their goods to can have a greater supply of these things if farming is modernized. For example, now we are dealing with getting a model that is going to help us differentiate between rotten fruit and fresh fruits. And these fruits will be used in the industry. So if it is faster, if this model works perfectly and then this process is faster, that means more juice is going to be produced, or maybe more whatever is needed to get to come out of these fruits that we're going to be, because we are dealing with bananas, we're dealing with apples and oranges, and all these can be used to make different things. So imagine if we get this model working within the shortest possible time, and then it helps these industries to produce whatever they are making at a faster rate. That means Uganda's export supply is going to also grow bigger, and therefore it is going to solve a very big problem. So the problem that we are dealing with now is being able to sort these fruits into fresh and stale, so that we can know the fresh ones that are needed and are required for this kind of activity in the shortest possible time, without being inaccurate, without being less efficient, because the human body can get tired. So if these people are working under tired conditions, they can easily mistake some fruits to be fresh and yet they're stale. So this is the problem that we want to deal with. And then the questions that we're going to ask ourselves, the AI research questions, for example, are how will this project ensure data privacy for the model users? If the users of this particular industry want to keep their information safe, if they have this number of fruits and they don't want their customers to find out that their suppliers have a loophole, how will they be able to keep this information just within their community? And then how will deep learning be implemented in our project? What are the types of learning algorithms that will be needed? Which learning algorithms will we use? And then the hypothesis, the project is developing a model which will use information on color, shape, and probably even texture sometimes, like an orange. When you feel an orange, you can know that this orange is rotten and this one is fresh. So we are dealing with bananas, oranges, and apples. And this model is going to have cameras where it is going to use image processing. So you put a fruit at the model, at the camera of the model, and then it detects if this fruit is healthy for consumption or if it is stale, and then it will be thrown away. We all know how fresh apples, fresh oranges, and fresh bananas look like. So this information is going to be transferred to the model, and like we learned, supervised learning, it will be able to determine if the fruit that has been placed on the camera is good enough for consumption. And then our research objective is to make sure that we identify every single fruit by its status of freshness. Is it stale or is it rotten? Or is it fresh? Or is it very good? Or is it somehow good? Or is it about to get like that? So that we can be able to determine how well we can use these fruits in the industry to manufacture whatever we want to get out of them. And this is going to be a nice project because it's going to help producers and factory owners, industry owners to manage their time and activities as they deal with these things, because they'll be able to identify the fruits very fast and carry out all their manufacturing activities as fast as possible. Thank you for listening.